Merry New Year. Okay. So, a couple of things. We'll talk more about the timeline here at the end when I'm done with most. I don't plan on going the entire time today. I plan on going maybe 2 months today and then giving you some more time, et cetera, et cetera, et cetera. But so just so you know, we've got a recap of 4-7 today, because we were basically done with 4-7 before break, but then break hit at the wrong time. We needed one more day to we didn't want to give you a test to do over break, so we kind of delayed it. So we're going to do the summative and then start reviewing for your semester final for next week. Okay? So you actually already have the semester review packet, or the worksheet, I should say. It's in that packet of stuff that you got before break, with all it has the graphic stuff on it, the first fitting notes on it, the last 4 pages of it is, or 4 sides of it is. You got that already? And then yeah, we'll be good to go with all of that. All right. Jump into refreshing our memory. So back before break, we talked about inverse trig function. Okay. And so we had an inverse sine function. Now remember, sine, we'll put that one, we'll put this one over here. So sine function over here started in the middle and went up and down, and it kept going and it kept going and it kept going in both ways until it went up. When we invert that to the inverse sine function, now I gotta remember which way it goes. There was our inverse sine function. I should say function. This is our inverse. Okay? But that's not a function. So we said then, let's restrict the range of our function to that. Because then this would be negative pi over 2, this would be pi over 2, and we pick all of our values from negative 1 to positive 1. Which we basically said was the right side of the unit circle. So when we're using inverse sine as a function, we restrict our values to the right side, the right half of the unit circle. So all of our output have to be between negative pi over 2 and positive pi over 2. So if it's not in that value range, we can't write it down. So for instance, 11 pi over 6 is on the right half of the unit circle, but 11 pi over 6 is not in this value range. you would say that instead of saying 11 pi over 6, you would say negative pi over 6. Because negative pi over 6 is down in green and same as 11 pi. Saying the same thing, but making it easy. Okay? Then we went to cosine. And we did basically the same thing. We said an actual cosine that inverse, we flip it around. But again, doesn't make a function. So we restricted it. And this time we restricted it to here. But that was negative 1 there, 0, and pi there. So we restricted this one to the top half. Cosines is a nice and easy one because whatever you get, you get. You don't have to worry about those negative values. And then finally, we get tangent. Tangent is a funky of the funks. Tangent has vertical asymptote in it, which means that we invert it. Instead of having vertical asymptote, now we have horizontal asymptote. So we again had to restrict it to make it be a function. So this time we restricted it again to the right half. So the restriction is the right half. except the only thing that changes on this one is for our output, now we can't have it be exactly negative pi or positive pi over 2 because inverse tangent doesn't work. Yep. So now using our unit circles, okay, inverse cosine of 1/2. So again, I'm thinking now, I'm looking at inverse cosine. So I'm telling my brain where on the top half, because it's cosine, is cosine equal to 1/2. Cosine from way back when we started trig with our unit circles and figuring that out, that was the x values, right? So I'm looking at the x values on the top half of the unit circle. Top half of the unit circle. I got an x value of 1, put 3 over 2, put 2 over 2, 1/2, 0, and then I go negative, so this is positive, so I would be right there. Agree? So that would be pi over 2. Now the difference between number 1 and number 2 is I go to pi over 3 in this one because it's not inverse, and I give the x value. So I go to pi over 3, the x value here is 1. With me? Yeah. So you got to kind of read it. And then remember too that we could also have arc cosine, arc sine, arc tangent. Those again are just meaning. Okay. So what I would like you to do now is you put on here. 8 of them on here. Okay. So I guess you can't use the unit circle for that. So what I would like you guys to do now is I would like you to do these 6 problems. Find the arc sine, inverse tangent, arc cosine, and so on and so forth. Okay? Go for it. So arc sine of negative 1/2. I'm looking right side of the unit circle. I'll put the unit circle down. So arc sine, looking right half of the unit circle, looking at where that the y value is equal to negative 1/2, and that puts me right there. But 11 pi over 6 is not in that negative pi over 2 to pi over 2 range, so I change that one to be negative pi over 6. It's in my range of that. Inverse tangent of 1, where is x and y equal on the right half of the circle? That would put me right here at pi over 4. That is within my output range. one is pi over 4. Mark cosine, that's top half of the unit circle, where on the top half of the unit circle is the x value, negative root 2 over 2. That's just there. This one is 3 pi over 4. Inverse sine of the square root of 3, where on the right half is sine equal to the square root of 3. Nowhere, because this value has to be between -1 and +1, and the square root of 3 is bigger than 1. So this is not possible. Or undefined, or no solution, none of those. Tangent of negative 2 pi over 3. First off, I have to figure out this is not an inverse type of problem, okay? Because I don't have arc in front or the exponent of negative 1/2. So I first have to go to negative 2 pi over 3. Here's negative 1 pi over 3. Here is negative 2 pi over 3. Negative 2 pi over 3. The tangent there we said was y over x. So that is going to be the fraction negative square root of 3 over 2 divided by negative 1/2. In the bottom, flip it. So then that gives me a tangent value of positive. But it's not inverse. That's why. That's why we have the whole circle square. And if it would have been an inverse tangent, this wouldn't have been applicable because we wouldn't have been on the side. Arc secant. Ooh, here we go. Arc secant. This. There, down, oh, well, arc secant, so secant, that goes with cosine, so this is really, so I'm trying to find where cosine, where the inverse cosine is 1/2. That's what I'm looking for. So, because if you think about it, secant, remember, is 1 over cosine. So if I have arc secant or inverse secant, that's 1 over the inverse cosine. So if I reciprocate then, that gives me what I'm looking for. Right side, so I'm thinking that puts me back at pi over 3, correct? For it to be top half, puts me at pi over 3. Agree? Then what we did is then we went and we did compositions of these trait functions. So when we're looking at composition, here for 1 second. So when we're doing compositions of functions, we start on the inside first. Okay? So the cosine at 5 pi over 3, that's down here is the cosine of 5 pi over 3. Cosine would be 1/2. So this is really the arc cosine of 1/2. So now, because now we're doing an inverse, now I look top half of the unit circle, and top half of the unit circle tells me where is cosine equal to 1/2. That's the one that we've been doing a lot today. 5. Agree? Try cosecant of arc. Oh wait, no, that's great. That's not on the unit circle. But now we're not on the unit circle anymore, right? Okay, because now we don't have pi's or anything like that, or values that are on the unit circle. So in that particular case, when we're not on the unit circle, then we should draw ourselves a triangle, and we should figure out thing. So for instance, theta is here, but we're using theta prime, which is fine. Cosine is adjacent over hypotenuse. Since we're dealing here with a right triangle, we know that this side then is 4. Pythagorean triple. If you forget, you can always do a squared plus b squared equals c squared and get that one 4. Okay. So arc cosine right here, this part is basically giving me theta. So I'm looking for here now the cosecant of theta. Since arc cosine was negative, that's why I drew my triangle in quadrant number 1, but quadrant number 2. But really, you can draw your triangle however you want to draw your triangle. It doesn't matter. Okay? As long as you know which angle you're going off of in your triangle. Okay? So the cosecant then is going to be 1 over the sine of theta and the sine of theta is going to be 4/5. One divided by 4/5 is 5/4. So my answer here is 2. Since we did some algebraic type 1. These are a little more complicated, so I definitely want to go over these. I'm in quadrant number 1 because my tangent is positive, or because inverse tangent is right side of the unit circle, positive in quadrant 1, negative in quadrant 4. So I'm in quadrant number 1 here. Tangent is co-op, opposite, over adjacent. So x divided by 1 is x. So I've got an opposite side of x, an adjacent side of 1. But now I have to use our old friend Pythagorean theorem. 1 squared plus x squared equals, call it h squared for my hypotenuse. Square root both sides. I get that as my hypotenuse. So I'm looking for the cosine basically of theta. Cosine is adjacent over hypotenuse. My adjacent side here is 1. My hypotenuse is the square root of 1 plus x squared. So that is the cosine of the inverse tangent of x. And for purposes of compositions of functions, we will leave them rational. At the rational end. Okay? I would like you to try secant of the arc cosine of x at this time. So these are really good problems. There's a lot of different maths involved with them. Cosine is adjacent over hypotenuse. That setup this time. Got to run Pythagorean theorem on it. 1 equals x squared plus b squared. So then that's going to be 1 minus x squared plus b squared. Theta, secant is 1 over the cosine of theta. Cosine of theta is adjacent over hypotenuse. That's that. I just go over x. Yes? Questions on any of that? Okay. So, for the remaining time that we have here, I kind of just want to talk about, because I've got more if you wanted to see more, but we nailed those, so I'm good with those. We're good with all those. So let's just get get right to the point. Okay? So the last test of the semester will open up this week Thursday, and we need you to take it over the weekend. So obviously Thursday or Friday would be the best for you to take because we're running low on time. And as we talked about earlier, next week Friday is the last day of the semester. Okay? We also have Unit Circle Extra Credit Project, and that is totally optional. If you, for you guys, because you're Group A, talking to people here in person, for you guys, it's due on Thursday. Okay? Group B students, we extended that to next week Tuesday for you because then you don't have to make a special trip into school to drop it off. Okay? Virtuals, yours is also due this week Thursday. Okay, we just extended that day for the Group B'ers so they didn't have to make a special trip. Okay? Virtual people, if you want to drop it off in the main office, that's fine. I got an email, somebody dropped theirs off today or this morning already. That's totally fine. We can do that. Okay? We are grading them on the 12th. So Group B, if you don't have it in on the 12th, you don't get it in. Okay? Totally optional for that. Okay? So then we have some people that are missing some things, homework, some reviews, some formatives, and some people are still missing some tests. Okay? So anybody that's missing anything from semester 1, those are going to be due. We're going to shut those off on January 13th. So that's next week Wednesday. So you've got a week and a day to get anything missing done. Yep. We're going to turn them off. Everything's going to be shut off at that point in time. Okay? So make sure you get some stuff done. Okay? Then, the final exam, you will have a semester final in here. It will be 30 to 35 multiple choice questions, and it will be taken on It's Learning. Okay? We're going to open it Wednesday, January 13th. Okay? And we're going to close it Friday, January 15th at 3 p.m. And that is a hard deadline because Friday the 15th is the last day of the semester. Okay? So if you think about it, because you guys have all been at school for, finals before, Wednesday, Thursday, and Friday of next week would have been your normal finals days. Okay? Everything is due at the end of the day on that Friday, which is what we have. Okay? So that's exactly what we have. Nothing has changed for us. Yes, what does that mean to you? No, because it's all graded on It's Learning. So you're gonna have to take it on It's Learning no matter what. I mean, if you want to take it in class on Wednesday or Thursday of next week, that's your choice. We'll let you do it. Okay? Our plan for today we were doing this. Tomorrow we're going to review more, do some more review problems on 4, 5, 4, 6, all that stuff. Talk about some more things. Thursday is basically if you want to take the test on Thursday, if you're in class, that's fine. You can take the test here in Thursday in class. Okay? Friday, get stuff done. Monday, get stuff done. Saturday, Sunday, get stuff done when you're not finishing football. Tuesday of next week is going to be semester review. So we're going to talk about the semester review packet, talk about some of the questions that are going to be on the final, et cetera, et cetera, et cetera. And then next week, Wednesday, is going to be more semester review if you want it, or if you want to take the final in class next week Wednesday. Same with next week Thursday. Review, we'll take the final over. I don't remember because it's not the NCC final, so it's not. But I can't remember what we have to say. I'll look it up. Good. So remaining time that we have now in that packet of stuff that that you have, there are some 4-7 sheets in there. There's a 4-7 inverse review worksheet, 4-5-4-7 review worksheet. There's a worksheet 4.7, and there is a 4.7 inverse trig functions in ACT prep sheet. So there's 3 worksheets that you can be working on at this point in time. At Homer's, I am done. I will tell you that if you have any questions, feel free to stay on. So yeah.